Hello and welcome to the MS SQL Tips webcast, SQL Server on the Google Cloud Platform, sponsored by SIOS Technology. I'm Greg Robidoux, co-founder of MS SQL Tips, and today's webcast host. Joining me today are Brandon Jung from Google and Dave Bermingham from SIOS. And today they will share what you need to know to create a highly available solution for SQL Server on the Google Cloud Platform. Before we get started, if you have questions, you can submit them at any time during the webcast by answering your questions in the question area in your presentation controls. We will try to answer as many questions as possible during today's webcast. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's event. So at this time, I'm going to turn things over to Brandon, and he can get started.
Good morning, all. Appreciate you all spending some time with us. Today I'm going to spend some time, we're going to go in sort of a foundational up view of the world. And so we're going to start most of the day going through the first part of the day, I should say, will be divided and focused on work that we're doing at Google that underpins what matters to you as a SQL Server user or admin. So some of this is going to be interesting. Ideally, we're going to go through a number of the stories, give you guys a number of the use cases and why and how customers are leveraging it. And then we're going to bring it home with David, who obviously be the expert here with us around the SQL Server world. So let me spend a little bit of time here. I'm going to make an assumption from the audience that most of the audience is probably not as familiar with Google because I don't know that the first thing that comes to mind is Google equals Windows, but or Microsoft platform or anything of the above. And we do, and it's been something we've invested very heavily in over the last 4 or 5 years, and have a really strong, robust offering. That said, clearly the direction that most customers will be is you guys are experts in the Microsoft world, and most of what you'll interact with is directly inside the Microsoft GUI and everything else. So what we thought we'd do is start a little bit of what's going on behind the scenes and how and why that might make some difference to y'all. So I think some of this will give you guys some directions on where Google has come from. And so I think a lot of people might know Google from the products you might see on the bottom. If you are using Google Cloud Platform, thank you. We love you guys as a customer. It's been a fantastic journey and taken off and continue to just be just a blast and doing really, really well. But I think most people, come to this with an understanding of what you might see on the bottom line here, which might be a search or YouTube or an Android. As it turns out, everything you see on the bottom is a product that now supports 1 billion users every day or more, some of them pushing, in case of Android, connected to about 3 billion a year or 3 billion a day. And so the first question and part to this is Google serious in this space? It's our biggest investment. So top down from an engineering, from a sales, from a development standpoint, Google's biggest bet is Google Cloud Platform. And we've been excited on where it's gone, but I thought I'd give you guys a little bit of history to that. Google comes at this market and what we're trying to solve through in a quite a different way than anyone else. And that's largely because of what you see on the bottom line is we've started with delivering these cloud services to customers at scale, massive scale everywhere. And so that means a lot of the innovation that we had before has come in, of course, Google Cloud Platform. But I think as a customer, the most important thing to understand is because what Google has to solve for these, which are the hardest problems on the planet, that innovation comes right back to you guys as customers if you're working with us. And so there's a lot of things that we do well. I think I'm going to spend a little bit of time because I think security is actually a place that it's a place we've proven we've gone into customers to be really, really differentiated. And I'll give you guys a little bit of color from that standpoint. When we look in terms of what Google delivers, everything that Google makes from a server, from a rack, from a networking, it's all custom. And so that means that we're able to deliver and provide in-depth security at every level of the stack, right? And so security isn't about just having the best secure perimeter, that matters, but it means being able to solve that everywhere that a customer might interface with that, or that a hacker might try and hit against it. And so we build things to our specs, and we build them, which means you can't reverse engineer this because it's a Cisco server or a Dell server. Both great, but like, again, these are things that no one can get to except Google. We do some really interesting things, and you'll see, I'll go through some details here, but you look at it from a hardware standpoint, every place and every server, network card, et cetera, has on it something called a Titan chip. It's a very, very small security chip, but those security chips restrict access that can be started or have been touched in any shape or form. Likewise, actually, our networking protocol is all proprietary inside of Google, so no one actually knows what that would be. So that's something that you as a consumer of our platform would never need to know. Certainly doesn't affect you in any way, but it means that from a security stance, we're in a very, very different place than anyone else might be. Likewise, just from a size and a scale standpoint, work that we end up doing in this space comes out in ways like you saw maybe yesterday when we gave the world access to what are called tensor processing units, right? These are custom chips that we have built from the ground up. TensorFlow is one of the many machine learning tools that Google uses, and with TPUs or tensor processing units yesterday, similar kind of the next evolution of a GPU. What you'll have seen in there is that now we give customers access to Google Cloud to compute power there to do machine learning, do forest trees, all of the stuff you might be looking at in an AI or an ML space. And a TensorFlow or a tensor processing unit performs in roughly at least 10, sometimes 100x better than a GPU, and probably in a 400-500x maybe better than a CPU for those specific workloads. And so that's the kind of stuff that we're developing, and then we're externalizing out for our customers to consume. The other area that let's go forward, next one, is there's a big investment that Google has placed in security in the broader internet. This is going to be all the way down to the Linux kernel, and I put this up in front of you because I think probably this is very apropos to what you as users have probably faced over the last month and a half with Meltdown and Spectre. Some history on this, on how this came about, which I think is pretty interesting. These are really big security holes. They are down at the chip BIOS level. These were discovered and surfaced, I should say, they were surfaced to the world, and the world found out about them in early January this year. Google actually found them 9 months before that, and had worked diligently to come up with some very creative ways to ensure that this could be solved. Not just for Google, but we had then worked very diligently with Intel, with the OS vendors, to get them all of the best practices for patching and solving this problem. This problem will exist, will continue to exist, and we expect more. This was found by a team at Google called Project Zero. And why this matters to you, so the Project Zero team is 500 plus engineers that only focus on finding the holes that are in the internet that could be exploited. And that matters because this is the kind of investment that also, by the way, the previous one you might have heard of is Heartbleed. All of these security vulnerabilities are ones that we invest heavily in making the entire global internet secure. There are some things uniquely you can do on Google, and we'll get into those, but we're able to patch these. So actually our customers running on Google Cloud Platform, if you were running a Chromebook, if you were running anything that really was either Google hardware or software, was actually patched in roughly August of last year. So a full 5 months before anyone else in the world even knew really it existed, we had found it, patched it, and our customers were secure. This is kind of the investment we're going to make, and it's proven out time and again to be truly differentiated and mattering to our customers and why they're making the kind of decisions. Couple of the things that we spend a lot of time around, breaking high level, look at our security thinks of a couple different ways. We look at protection from threats through a secure foundation. I talked a bit about that with our core infrastructure that's designed and built from the beginning to secure Google from external actors. I'll leave it at that, but you can imagine there's a number of them. And second, then we provide our customers with the controls as well to make sure that you all have the identity and access control you would need, the encryption and the like. And then finally, we just check off the boxes because, you know, at the end of the day, everything's got to have compliance. We could go down a different conversation that compliance might have its own it's its own business in and of itself. And the truth of the matter is it takes a lot of time and effort to make sure that you check all those boxes and you can deliver that at scale. We also think of both security and the infrastructure itself all the way across the entire board. So at depth, across how it matters and shows up at the internet communication. An area here, if y'all are interested on a security side, so if we have anyone that's real interested on network side, I'd encourage you to take a look at a white paper and a tool that we call Beyondcorp. Beyondcorp is functionally how you go about securing end users against a zero trust network. And we've actually surfaced that as a product on our platform called Identity Aware Proxy. So some very interesting stuff there, internet end user view of the world. Obviously, I talked a little bit around our identity, but a very, very robust identity access management tools. These work and are synced with your AD. So again, with everyone here, happy AD runs great on GCP. We love that. That said, there's also a number of our tools, easy syncing for identity access management, and then really robust granular access inside of your projects and stuff if you're running this on top of Google Cloud Platform. Talk a little bit of hardware infrastructure, but I'll probably take a step forward here and look at that specific hardware that we are designed to. So all of our stuff is custom built for Google, literally from chip to chiller, right? The precise requirements that we have, including security that gets built in at every single level. They're designed and custom built. They don't include, for example, they don't include any unnecessary components like video cards, peripheral interconnects that introduce a lot of vulnerabilities. And those are oftentimes the place that vulnerabilities show up when you're buying or running stuff on gear that is not custom made. Same goes for the software, right? All the way down to the low-level software, including our operating system, which underpins cloud, which Windows runs on top of. It's stripped down, it's hardened version of Linux that has none of the extra vulnerabilities that oftentimes get exploited. Only thing that needs to be added are in there. We designed hardware specifically for security, like I said, the Titan chip that we use to establish that hardware root of trust all the way in the servers and all our peripheries, as I had said. And we also build our network, which is completely custom built top to bottom with hardware. And there's a whole bunch of details there that I can, if someone wants, ping me, happy to get that out there. But Andromeda and Jupiter are big network white paper was written around how we handle both security as well as massive throughput, which again, if you're running a robust database becomes extremely important, especially if you do it in HA, which is what we'll get into here in a little bit. So end of the day, understanding the provenance from top to bottom of a hardware stack, as well as the security, puts us in a unique place from a security profile and a posture. We build all of these ourselves. And so the other route that we go that you should look at is, we think open source is wonderful, but when you're looking at security, it also is at your core something that useful, but if you're taking just everything open source and putting it in your underpinnings, it takes work to make sure that that is both patched, security is always up to date, and that you can quickly roll that out. So other thing here that we know customers care a lot about, encryption is default. This is actually an extremely difficult problem. It's not difficult to encrypt something that's on a disk and throw a key on it. That's pretty well understood. What's challenging is encrypting data by default in transit at rest. At rest is easy, and transit is very difficult because usually, traditionally, you will pay a very big overhead by doing that. But everything that enters into Google's network requires a TLS, as we said, to get in. The data is chunked up in a whole bunch of little pieces, and each piece is given its own data encryption key by Google and managed and secured everything through our encryption keys. Likewise, if a customer would very much like, and a large number of them do, want to bring their own encryption key, they are welcome to put their encryption key in addition on top of our encryption. Everything, of course, is 256 and everything that one might expect. This all happens seamlessly on the back end without any performance hit. And so that's something that, again, takes massive amount of engineering work to be able to deliver seamlessly, and just something that comes with being on the cloud, on our cloud platform. It's also something that is not the case for any other public cloud that can do the encryption in transit and at rest, and it's all, like again said, done by default. A couple other things that we're investing in that's kind of interesting. Certainly, we're seeing a huge number of customer growth, and in that massive growth, we actually said this publicly. Last quarter we're running well in excess of $1 billion a quarter. So we're, probably, you can do extrapolation. I actually can't say anything more than we officially said, but running well over $1 billion a quarter with our customers, which means that's great. We get to make an investment. What's different in terms of where we make the investment is, as a customer, it isn't your business which we love, that is fueling our growth. It's actually the rest of those big services that you saw, the 8+ that are running 1 billion users. That allows us to make investments like we have in excess of almost 30 billion over the last 3 years, just in our network alone as well. This is something that we'll continue, of course, to invest because the growth curve on the other platforms is accelerating massively as well. And along the way, what we'll find is that a lot of the innovations that Google has to solve for, serving you the world's best videos of cats, will be ones that you can actually will make a huge difference to the core networking that you get to sit on when you get a global network that's second to last one here that we'll go into is compliance. And so the compliance piece that everyone needs to meet is all of the things around the data restrictions, third-party audits and certifications, data deletion, sub-processor requirements, and everything you might hit in EMEA. Those are ones that come up very regularly. And as normal, here's all the wonderful stamps. I'll pause for a couple moments because I suspect a number of you have specific requirements that you need to hit. So feel free, whether that's any from a FedRAMP or it's the ISO or it's the HIPAA. These should largely cover almost everyone's requirements. Again, more ones will come out, and as they come out, we will invest the time and effort necessary to make sure we keep up with them. So last thing, I want to spend a little bit of time in what the heck is inside of this world and why is it done differently. Google, I'm sure containers, everyone has probably heard the world of containers, or if you're not, you'll get to hear them a whole bunch in the near future. Why do they matter and what do they do? Well, Google itself runs everything in Google with an inside of a container. That allows us to have a much stronger security profile, so kind of back to security, but it also allows us to do a whole lot of very interesting things around the management of resources and how we handle that. And so back when we first launched, or when we looked at offering basic VMs, right? And that's for us, Google Compute Engine. We looked at it and we had two options. And one option was to take a traditional server and put a bunch of VMs on it. The alternative was to figure out how to put KVM and put a kernel that you would run it, so a VM, inside of a container. Well, no one had done that before. And we made the investment. It took us a good 1.5 years to do this perfectly, so re-engineered from the ground up. And what it does is it allows us to run every single VM that you touch inside of a container, which sounds, why do I care, right? Well, we obviously launch and run a bunch, which is nice, but I'm going to get into a couple of very unique things that, because we made this heavy investment, this unique engineering investment, what you'll find is that we actually are able to do some things that no one else can do. Now, all of that, of course, requires that it sits on a really robust, big investment of infrastructure. Everything you see here, all little green dots, are data centers that you can run your workloads in. And if you look at this as well, all of the yellow are ones that we'll open up shortly. So at this point, this probably looks a bit like anywhere else, which is you have infrastructure you can kind of run on anything, anywhere, on any continent. What is quite different on this will be actually the lines. So if you went and you looked around and asked and checked with people in terms of, hey, I've got zones and regions which are useful, The difference is that every one of those lines are network, cables, and investments that Google owns. So we have the second, likely, possibly shortly, the largest network in the world. And we use it, of course, to run both our infrastructure, but what it does is it allows us to do fairly unique things for our customers. So we have the only public cloud that has multiple network tiers. So we have a standard network tier, which looks just like an Amazon or Microsoft, which means when you exit a Google data center, you get to transverse the internet. Well, alternatively, you can use our premium networking, which is the same price as everyone's standard networking. And at the premium level, you actually run all of your stuff, again, runs encrypted across all of our dark fiber. And I should say actually our fiber. It's not dark, it's quite light actually. And that's where our customers would run this. And this allows you to do some crazy fun things. For example, we have a number of customers that have a single golden image of a operating system. So you have a custom version of, say, SQL Server 2017. We obviously host that. We have a version if you want to just launch it, but say you have one that you want. That version you can boot from disk. If you're running in Oregon, you can literally boot from disk in Mumbai. You don't have to make copies of it. The speed is insane. On top of this, by the way, we also run the world's best CDN. Bar none, it is the best CDN. So we have CDN plus core networking that's quite powerful. Now, what I want to do, though, is take, yay, engineering, and let's make it in something that matters. So in the last couple of minutes, I want to go through converting what are geeky pieces, which, again, I love, I'm sure all of you enjoy as well, but why do they matter? Well, we have a couple of things. So I talked a bit about containers, and we run them. We run them inside of containers, and that allows us to do something called live migration. What that means is when we want to patch a host, when you have a Spectre, or a meltdown or a heartbleed, we can patch that host, and we can patch the entire host and move a customer onto another VM, another host, and they will never know that that happened, right? We have done this repeatedly with large customers of ours like a Spotify or a bunch of streaming, and you can stream a 1080p video. We can do the live migration, and the customer will never know that that just got migrated from one host to another. This allows us to do maintenance, allows us to do patching, and most importantly, gives us excellent security. Also makes it much easier for you as a customer because you don't need a patch, and you don't get outages that you have to, migrate around. And when we're running a database, that's always a challenge, is figure out when you can take that offline. We have per second billing. This is something we've always led on, which delivers great, truly elastic cost. We have VM migration services, so if you're running it on-prem and you need to move to Google, great stuff there. And then once you move over, we have resizing. You can resize all your disks on the fly, SSD, HD, you get the idea, which is excellent because in a net, particularly in SQL Server, your database may grow, you may have different performance requirements, and being able to change and resize those disks on the fly is pretty important. The other area, and this is where having, again, back to the containers, VMs in a container, you can do custom machine types. So anyone that's used to being able to choose a public cloud is used to the 2, 4, 8, 16, 32-way VMs, and that's what you get to choose from. On Google, you can have a 14-way, or you might want an 18-way, and you can combine that with any combination of memory that you would want. Pretty powerful. Means you aren't overpaying. It also means that you can resize down to pay the right amount. It also allows you to easily scale up. You don't get caught in a spot that you have a robust SQL Server database that's at 16-way machine and you need to go to 18. Who wants to pay double to get to 32? Great, go to 18. You're off and running, right? And you can adjust as well. We have sustained use discounts. This means if you run a VM for the month, we give you a 30% discount. You don't have to do anything else. It just happens. So while you're getting started, this is great. And likewise, if you're not really sure and you're not ready to make a big, long commit for a year or 3 years, this means that you get really all that value with none of that commitment. It's what we think of when we say public cloud. That's kind of really what we've always thought it should be there. We recommend recommendations with one-click resizing in the console and everything. Our throughput storage, you don't pay for it. So most other public clouds, every other public cloud, you have to pay for IOPS. We have scalable IOPS based off your size of your VM, and It's always there. It's always consistent. And again, we can do this because we can ensure that you don't have a noisy neighbor because we have live migration up above. And so this means that we can ensure seamlessly that every customer is getting the very best throughput and the very best every single day. Last one too we have is Preemptive Vms. These are excellent. Do not use these for production workload because they can disappear in 30 seconds. That said, you get an 80% discount. So if you're doing scalability tests or you want to, you're running something in a test dev environment, these are awesome, right? Great tool. You know exactly what's in the cost and you're up and running. And last one is just super fast boot time. That's pretty nice if you've got to, if you got to create a new instance or you have an HA environment. Our boot up seconds in terms of speed on that, and that's something that matters an enormous amount. So last one, and this comes up pretty regularly. We wanted to share with you guys some details. You're all welcome to go out here. It's called cloudbenchmark.com. We've worked together with all of the companies you can see, industry partners, to put up very regular benchmarks that everyone can agree to. And to that end, you'll see, of course, Microsoft's in here, Red Hat, Canonical, Cisco, really all the big players that might be in there. And you have these benchmarks around the three big public clouds. They are also in GitHub if you wanted to go and run those yourself. So I hope these are helpful. Foundationally, this is what you're sitting on. And so as we transition over this and David goes through the details of SQL Server, you're going to know this is what it's running on. And these are some of the tools and core engineering that's allowed us to do what we've done and do that with SIOS. So with that said, let me transfer you right on over to David. And
great, thanks, Brandon. So as we make this transition here, I think, Greg, we're going to start with our first poll question. So you might as well get that up there, and we'll continue with the presentation.
All right, so the first poll question is launched. So the question is, are you currently running or planning to run in the next 6 months SQL Server in a public cloud? So give everybody a little time to vote on this, and then I'll share the results. I get a good amount. Let's give another 10 seconds here, and then I'll share the results. All right. So we have 46% said yes, 29% said no, and 25% said don't know.
All right. So about half there or there very soon, and I'm sure from what I've seen personally at SIOS, more than half of our new opportunities are for cloud deployments, and so cloud is really taken over as the vast majority of our new opportunities. So that kind of jives with what I'm seeing as well. That's good to know. So, Brandon gave us a lot of really great detailed information about the Google Cloud Platform and some of the differentiators. And I've been playing with the Google Cloud Platform now for probably just over a year or so. And deploying SQL Server in the Google Cloud Platform is, regardless of what cloud platform you choose, you have, the cloud platform provider gives you tools and has some amount of resiliency built into the platform, but they basically giving you the tools so that you can build highly available instances of SQL Server. And in the Google Cloud Platform, we're talking about leveraging different regions, and within each region there is something called a zone. So there are independent data centers within each region that, to have a truly highly available instance of SQL Server, you're going to want to have minimally redundancy across zones, but even potentially redundancy across geographic regions as well, or a combination of the two. And when you come down to building your availability for SQL Server, you come down to the tried and true options that are listed here. You have the SQL Server Always On Availability Groups, or you can use the SQL Server Always On Failover Cluster Instance, the good old just Failover Clustering SQL Server. And now you probably may or may not realize that SQL Server Failover Clustering traditionally would require some sort of shared storage device, and all your nodes will be connected to that shared storage device. In the cloud, that that type of environment just does not exist, and you want to have a redundancy across different regions or different zones. You can't really have that storage because the storage would reside in a single zone, which could be seen as a single point of failure. So both of these solutions rely on some sort of data replication to keep the data in sync across the different cluster nodes, and they each do very similar, functionality in terms of, making sure that your databases stay online. There are some key differences as I outlined here. The SQL Server Always On AG, and one of the primary reasons that customers come to SIOS for high availability is that for the fully featured version of availability groups, it requires SQL Server Enterprise Edition. And we'll go into some details of the cost of that, but it's quite a substantial increase in the overall cost of the solution to go with SQL Server Enterprise Edition. But beyond the cost, there are other reasons that people might use failover clustering versus always on availability groups. The always on availability groups replicates the user-defined databases. So if you create a database, you can put it in an availability group and create replicas of that for high availability as well as disaster recovery. And even one of the nice features of availability groups is to have readable secondary. So you can define one or more of your targets to have read-write access, and then you could run reports or do backups or so forth to offload some of the load to your secondary servers. Always on availability groups, with the SQL Server Standard Edition, you can build a 2-node failover cluster instance. And that instance, the failover cluster instance, replicates the entire SQL Server instance. So we're talking about not only the user-defined databases, but also the system databases. So MSDB, all your agent jobs, your logins, your passwords, everything gets replicated and fails over as a whole. Now, to enable failover clustering on the Google Cloud Platform, you're going to have a third-party data replication solution, such as SIOS DataKeeper, which we're going to talk about a little bit more later in the presentation. The failover cluster instances do not support readable secondaries, but with the DataKeeper solution, you can do a point-in-time target site snapshot, so the volumes containing the databases can be made available for read-write access, which you could then mount from another instance of SQL to do your month-end reports, or do a robocopy to archive storage to supplement your backup scheme. We talked about the cost really being one of the driving factors of people looking for an alternative to always-on availability groups. And this is just a picture of just the software cost in comparison. So we see the dark blue line is the cost of SQL Server Enterprise Edition based upon the number of cores. And right before the presentation, I realized a mistake here. One of the limitations of Standard Edition is it only supports 24 cores. But you can see roughly the cost is twice or more than twice the amount, even including the cost of the DataKeeper software in addition to the SQL Server licensing. So this is a view of what it would cost to run SQL Server for an entire year in the Google Cloud, depending upon the number of cores you need to license. So to look at that in a different way, you see the cost savings. So if we decide to go with a failover cluster instance, leveraging the SIOS DataKeeper software, and you run that solution, let's just take any of these, we look at a 16-core solution over the time period of 3 years, it's roughly almost $200,000 in cost savings. And you know, in 5 years, that same solution would save you over $300,000. So once you start doing the math and assuming that, you know, you don't have any other, the only reason that you're looking at Enterprise Edition is for the always-on availability groups. If you're fine with 24 cores or less, then it becomes a very, you know, a very cost-friendly solution for you to consider. But as we mentioned, it's not all about the cost. And, you know, there's other reasons why people are looking at alternatives to always-on availability groups. One is the ease of management, and it protects the entire system, so including your system databases. Availability groups does not do that. It only replicates the user-defined databases, so you have to manage your agent jobs, your logins, and passwords in some other fashion. Failover clustering replicates and fails over the entire instance. Distributed transaction support, the story has been changing with each release of SQL Server. They started having limited support with SQL 2016. They can support distributed transactions across different instances, but not within the same instance. Finally, with SQL 2017, they seem to have solved the problem. So you need to consider that when you're looking at what, you know, deploying SQL in the cloud, what version can you go with? Do you need to support distributed transactions? So you should definitely be aware of that. And database administration, availability groups, you're continuously adding and dropping, you know, if you're you know, have databases coming in and out of the picture, you need to account for that. With the failover clustering, once you configure it, anything you add or drop is automatically part of the protection scheme. So it's very much easier to administer, and it's all administered through Failover Cluster Manager, whereas the always-on availability groups, there's some management in Failover clustering, some management in SQL Management Studio. So this all falls under the same umbrella. And then if you have data outside of SQL Server, so you have some image files or some file shares that you need to replicate and put it in a cluster, the availability group is not going to be able to help you there. So the failover clustering not only takes care of all your SQL Server HA needs, but really any application or any data that needs to be protected in the cloud can be protected with the SIOS DataKeeper solution and failover clustering. And then finally, scalability. You may or may not know that with always-on availability groups, as you add more databases, more worker thread processes are consumed. And while there is no, you know, hard limit in terms of the number of databases or availability groups you can deploy, Microsoft will say they've, you know, tested extensively against 100 databases and 10 AGs. You know, mileage may vary. It really comes down to your hardware and how many worker thread processes you can consume before you consume them all. If you're talking hundreds of databases, you're definitely going to want to have a, you know, second look at doing a failover cluster with DataKeeper versus availability group. You're probably not going to be happy with the performance once you get to that number of databases. So Greg, let's take a moment and pop up this poll question number 2 here.
All right, the question's out there. And the question is, which of the following is most important when choosing a high availability solution for your critical workload in the cloud? So price, configuration and flexibility, ease of use, and other. So give everybody a little time to vote on this, and I'll share the results. I'm going to give it 10 seconds and we'll share the results here. All right, so we have 42% said price, 29% said configuration flexibility, 21% said ease of use, and 8% said other.
Mm-hmm. Yeah, and once again, that kind of jives with what I'm seeing. A good majority of our customers are like, well, availability groups might solve our problem, but we have to get the price tag, and so we're looking at alternatives and features, and simplicity is also obviously on top of people's minds when they're the ones that have to manage the solution. So that's good information. So we talked about deploying, highly available instances in the Google Cloud Platform. This is just a picture that, really, this could represent anything. This could represent your own data center. It could represent any public cloud provider. Just change the labels on it. It works the same, that you're used to. So if you're familiar with failover clustering or you're familiar with availability groups, I'm not going to go into great detail on those solutions, but just know that there's some amount of replication that has to happen. So we're doing synchronous replication between different nodes. Now in the Google Cloud Platform, what's pictured here is you have two SQL nodes in different, same region, but different zones. So we have a US Central 1A zone and a US Central 1B zone. And we're leveraging a file share witness. If you're familiar with Microsoft clustering, you'll know that you have to configure the quorum. Because there's no shared disk, you're going to use a file share witness for your quorum. In this case, we're going to put the file share witness in zone C. And by keeping each instance of the quorum, each vote of the quorum in a different zone, you eliminate the possibility of losing more than one vote should an entire zone go offline. So in this case, you could lose any one of these votes and the remaining nodes would continue to function just fine. You shouldn't notice any outage. And so again, it really, you configure it identically to what you've done in the past. With the SIOS DataKeeper, we'll see that at the end. They'll give you a little demonstration of how that works, but it's very simple to use to build failover cluster instances. But the only thing you really need to know is in the Google Cloud Platform that you have to manipulate the networking slightly in order for failover clustering to work properly. And that's the same situation you see in many other public cloud providers. The real problem is the public clouds in general, in Google and Microsoft in particular, they don't support gratuitous ARPs. So where traditionally you would leverage a virtual IP address that moves between cluster nodes, that by itself is not a workable solution. So in the Google Cloud Platform, I'm going to walk you through the steps, and I've documented this, and Google has documented this as well for always-on availability groups. And I believe Brent Ozar has written a white paper for Google on how to configure this for always-on availability groups. And SIOS, we have a white paper that you can request on how to configure this for failover clustering. I'll share some screenshots of that document with you and just give you a high-level overview of what you need to do to make this work. So first thing we need to do is, we got to build our network. So any cloud platform gives you all the tools you need, but you have to start from the ground up. So you got to build your network. And in this case, we're going to leverage the console to run some commands to create a network. So pictures here, first command is just creating a custom mode subnet. You give it a name. And then, so we have one big subnet, and we're going to divide that up into 3 individual subnets. As we saw in the picture earlier, we're going to put each node in a different subnet. So you see here that I'm creating 3 subnets, all in the Central 1 region, but we're going to leverage them later. We'll make sure that they all get into a different zone. So we have 10.0, 10.1, 10.2 with a /24 subnet mask. Now keep that in mind, the /24 subnet mask. So once we have the network configured, we're going to deploy our virtual machines. This is a screenshot of one of the configuration pages when you're configuring a virtual machine. Network interface. So each node you'll configure will have a network interface. In this particular server, we're putting in the subnet 1, the 10.0 subnet. We're going to define a primary internal IP address. That's going to be a static IP address that's dedicated for this instance. And the important thing here to see is the IP forwarding. We have to turn that on. So that's not on by default. We have to enable that. So we do that for each of our nodes. Each will have a different IP address, and each will be in a different subnet. And then once we have our instances configured, we have to go into the two SQL Server instances, and we're going to have to manipulate the IP address. So remember before I told you these reside in a subnet that has a /24 subnet mask. We're going to have to force it to use a /16 subnet mask, as you can see here. So by running these NetASH interface commands, we can set the subnet mask, force it to use a different subnet mask. And we need to do that, otherwise we wouldn't be able to do what we're going to do next in creating custom routes for the cluster IP addresses. So the final step here and pictured, and again, this is all documented in the Google documentation as well as our white paper. We are creating what I call host-specific routes. So if you look at this, and you know, I know not everyone is like a networking guru, and I certainly you know, have my challenges as well. But I'll try to really explain what we're doing here. We are creating, by creating these host-specific routes, I'm creating a route that's just for one IP address. So you'll see in this case, SQL Server 1 has two IP addresses, the 10.0.1.4 and the 10.0.1.5. Those are the IP addresses that I created when I built my cluster. So this is the cluster core IP address, and then this will be the IP address that's used for the SQL virtual IP address, or if you're doing the availability groups, it would be the availability group listener IP address. And because these are in different subnets, this is technically going to be a multi-subnet failover cluster. So you see SQL Server 2 has its own host-specific routes in the 10.1.1 network. So we have 10.1.1.4 and 10.1.1.5 that are destined for SQL Server 2. And because it's a /32 subnet mask, this is a host-specific route. So this route only applies to this specific IP address. And I know that could be a lot to take in, and you know, so read the documentation. But this is really, you know, the biggest hurdle in terms of getting things configured in the Google Cloud Platform is getting the networking done right. So I wrote a white paper to try to really explain that, simplify it as much as possible in easy to understand terms. So we're going to take a moment and take a look at the SIOS DataKeeper solution so you can see exactly how that works. So I have a demo connected here with two nodes, SIOS 1 and SIOS 2. And so if you're familiar with failover clustering, this is the failover cluster manager, and I have a cluster created. It's leveraging a file share witness that is just a file share of my domain controller. I have the two nodes in this cluster, SIOS 1 and SIOS 2, and I actually have a SQL Server cluster already pre-configured. So you can see the resources. You have your typical SQL Server agent, you have a name, you have an IP address. Where it's different from a traditional shared storage cluster is under storage. Normally you would see a physical disk resource. Instead, you're seeing a DataKeeper volume resource. This is our secret sauce. This is how we integrate with failover clustering. So right from Failover Cluster Manager, I can get information about the replication. I can see the current source is SIOS 2, which makes sense because the owner node right now is SIOS 2. It's replicating to SIOS 1. We're doing synchronous mirroring, and we see it's currently in a mirroring state. So everything looks good. From this point on, I just manage it like a regular cluster. If I wanted to move this to SIOS 1, I could just do that through Failover Cluster Manager. Watch resources come online, offline. The DataKeeper volume is already online. As part of that switchover process, SIOS 1, the node coming online, becomes the source of the mirror, and SIOS 2 becomes the target of the mirror. And all that happens automatically. So how do we get to that part? It's very simple. It's just software that runs on each cluster node. And you see I have a job that's represented in this little cluster here. SIOS, I'm representing the S drive. I'm going to create a new job and put it in the cluster. I'm going to replicate the R volume from SIOS 1 to SIOS 2. So three-step wizard, SIOS 1, choose the volume. You can specify which network to use for replication traffic if you want to do that. The target, SIOS 2, looks good. The volume looks good. IP looks good. And then here are your options. For local target, synchronous replication is the way to go. If this were a long distance replication across regions, you could do asynchronous. You could also enable compression. And you can also specify maximum bandwidth if you want to do that. But for our purposes, synchronous and local target is the way to go. Click done. That initiates the replication. In a moment, we'll get a pop-up that asks us if we want to register this in the cluster. I'll say yes, put that in the cluster. And so now if I look in my storage, I have a DataKeeper volume R. It's in available storage. So as far as the cluster is concerned, this looks like a shared disk, but it's really just local attached storage. So in the Google Cloud, you would, when you provision your virtual machine, you're going to add some additional disk to it. And those disks are just normal disks, just like you were adding to a standalone server, and you're going to format them NTFS. There's no fancy formatting. There's no iSCSI magic, nothing like that. It's just a regular NTFS disk. And our software is going to replicate one disk to another synchronously and integrate with failover clustering through this cluster resource. So I'm not going to build another SQL Server cluster for sake of time, but I'll show you if I were to build a what's called SAMless file server cluster. I just walk through the regular wizard as always and give it a name and an IP address. And here's the secret sauce where it says select storage. It recognizes the DataKeeper volume as an available storage type. I can just choose it, just like it were a shared disk, and hit next, next, finish. And now I have a SAMless file server cluster. Same experience for SQL Server. You're building a SQL Server cluster, create your base failover cluster, so you add your nodes to the cluster, configure your quorum. You're going to add some storage, so add some DataKeeper volumes and available storage. At that point, you run SQL setup to create a new cluster, walk through the wizard just like it was a shared disk cluster. Then run the setup on the secondary server, add a node to a cluster, and you have a SAMless SAMless SQL Server cluster. With that, I think I'm going to allow the last 5 minutes or so for some questions. So if you have questions, you can submit them online. And sorry, we probably should have told you that earlier. So, Greg, I'm not sure if we have any questions now, but we'll take your questions and hang on here for the next 5 minutes. And if there's any follow-up after that, feel free to reach out to us directly, and we'll get on the call with you and answer any other questions that weren't addressed today.
All right, thanks, Steve. Yeah, so one question someone has was, is there an easy way to test out the Google Cloud Platform, I guess without spending a lot of money or?
Yeah, I'm going to let Brandon handle that, but I know the answer is yes.
Yeah. Guys, on this, you are welcome to go directly to cloud.google.com, and you'll start out with there's a free tier that you can use, and there's a whole $500 of extra usage anytime you need.
Okay, great. The next question for you, Dave, is just related to SIOS. And is there an easy way, are there templates or anything that people can easily deploy cluster in the cloud?
Yeah, that is a great question. So we are currently working with the Google Cloud Platform and to have what we call a quick start template. So there's nothing today in the Google Cloud Platform. We have templates available in other cloud platforms, and so we hope to be on par with Google as well.
Okay. Let's see, another question, I guess, for you, Brandon. Somebody just had a question or a statement, I guess, that they didn't know that SQL Server could actually run on the Google platform. So can you just kind of talk real quickly about that? Is it a virtual machine, or how does actually SQL Server even run on? I guess they figured everything would be Unix or Linux or something like that.
It runs right there. So if you go in, if you want, guys, let's hold on. If you want to give me visibility, I can launch one right now, but functionally, it gets put directly onto a VM. So we have full windows of all varieties, and we have fully built out instances of, for fun, I can tell you exactly all of them, but every version of SQL Server and everything. So if you went into Compute Engine and launched a VM instance, you would be able to choose any kind of VM type. So in this case, when you guys look at it, they're pre-baked images for applications across all the SQL servers, and I think we've now got 20 different options from SQL Server 2012 running on Windows Servers 2012 R2, all the way up to SQL Server 2017 Web on Windows for there. All runs on Windows images and everything. So those are all there. Cloud.google.com, you can search it, or but it's something you can usually launch, and I'm looking at it right now. I just did a quick double check myself to launch, and it's all right here. And then you can choose your standard disk and all that. So really very straightforward, and that's all baked in, ready to go. Should take you, once you have an account, 3 minutes maybe, if that. I hope that answers the question. If there's more details to it, I'm happy to go more detailed.
That's perfect. Thanks, Brandon. All right, another question somebody had is, I'm not sure if this is too specific or not, but let's see if you guys have an answer for this one. But so we just wanted to know if their SQL Server instances are using file stream and file tables, and they're just wondering, can they implement that in the cloud?
Yeah, so I mean, the cloud is really just a data center that you're renting. Obviously, it's more than that, but you have full control over your SQL Server implementation. So you're running on a full version of Windows Server. You're running a full version of SQL Server. So every feature that's available in SQL Server is going to be available to you running in the Google Cloud Platform.
Okay. Let's see. Another question somebody had is just related to HA and DR. They're just wondering, is it possible to implement like a hybrid solution on premises and cloud with DataKeeper?
Yeah, absolutely. We see that all the time. So DataKeeper is very flexible in the configurations that it supports. So if you wanted to, you have an existing shared storage cluster on-prem, and you want to extend that into the cloud for disaster recovery, we can work in that environment. We can work in purely, all replicated storage solutions. You can mix and match physical servers, virtual machines, cloud instances, and it doesn't matter to us. So yeah, that hybrid on-prem to cloud is a very unique solution that we can support, where traditional DR solution might require that you use some sort of array-based replication solution, but that's just not possible when you're leveraging the cloud as a DR site. So that's where our software-based, host-based replication solution really fills a gap for that hybrid environment.
All right, let's see. Another question that came in was just related to data loss during a failover. So they're just wondering, what are the chances of data loss during cluster failover with DataKeeper?
Yeah, with synchronous replication, there's no data loss. So the data is always 100% in sync. So even in unexpected type failures, you're not going to have data loss. Asynchronous replication, which is lets you replicate greater distances, there, of course, is a chance of some data loss, particularly if you have automatic failover enabled. And the way that we can, support longer distance replication is, we don't have to wait for the writes to commit on the target. So those writes that have not committed on the target, but yet included on the source, are in the async queue until they're sent. So that data is at risk should someone pull the power cord on the source and you have automatic failover enabled. That's the data that's at risk. We're not talking about minutes or hours of data. We're usually talking about a few writes, and you can monitor the async queue through some perfmon counters so you can get a good idea of how many writes are in here at any given time.
Okay. All right, Brandon, another question for you is somebody just wondering, can they run SQL Server 2017 Developers Edition on the Google platform? Do you have that supported?
So the short answer is absolutely yes. So anything that you can run on Windows, you run on Google is great. I'm seeing if we have a specific one-click to launch. So by the way, all the things I'm talking about, like SQL Server 2017 Enterprise, all that stuff is a one-click launch. Like, hey, great, good, it's off. You choose its size, it's ready to go. Any other unique piece you want there? I will double check. I don't think that we have that as the developer edition as a one-click to deploy. But once you have you can launch Windows and just throw that on there anytime you want.
Okay, so they just gave like a blank VM and then install Windows. Install SQL Server. Okay.
Yeah. So obviously that's not as simple as I'm one click, 3 minutes later, I've got, a 64-way beefy, 500 gigabyte SQL Server instance, but obviously that's not what you were looking there. So the short answer is we've got a bunch of almost everything stock ready to go that you would probably put more think production, and then you can run anything you want. We actually run Windows. Price, performance, and efficiency is the best, even significantly better than Microsoft. Same price for Windows stuff is always the same. The real question comes to what that infrastructure looks like underneath.
Okay. And just one last question about that. Somebody just asked a question of about the charging and prices. So if the VM is up and running, I guess they're getting charged, but if the VM is not running, are they still being charged?
No, so what you could do, you can keep your information on a persistent disk, and then you're just paying for the disk. You obviously pay a cost when you launch, like there's a hit in terms of timing to launch a new VM, right? But if you want to keep your stuff in persistent disk and you don't need to be running a VM, then clearly it can stay in persistent disk. The time to obviously to a first hit, or if someone needed, to query something, clearly you pay that overhead. But our boot times are fast, so definitely doable. You're not paying for. You can turn them off, and your persistent disk stays around as long as you want. You can create snapshots and stuff. So that's pretty regular. Just be aware, obviously, the boot time and any config if you wanted to do on the VM. Obviously, the VM's not just sitting around, right? So we'd suggest you store that as a snapshot or a custom image yourself, and then that's in persistent disk. You can boot from that whenever you would want.
All right, great. We're going to wrap things up. So I want to thank Brandon and Dave for sharing the information today, and also thank SIOS for sponsoring today's event. The webcast is recorded, and you'll receive a follow-up email with links to view the archive and also to download the slides. Also, take some time and visit mssqltips.com to access all of our free SQL Server resources. Once again, I'm Greg Robidoux from MS SQL Tips. Thank you for attending, and have a great day.